All right, welcome back, everyone. For this session, we have Robyn, a fast async Python web framework with a Rust runtime from Sanskar Jethi. Please welcome.
Hello, everyone. Thank you for coming to my talk. I wish I could have been there in person, but unfortunately, due to some last-moment changes, couldn't be there. But thank you for the PyCon AU team for accommodating me to give this talk remotely. And thank you to all of you for attending this talk. So today we'll be talking about Robyn, which is a fast async Python web framework. But before we start, a quick introduction about me. My name is Sanskar. In the mornings, I work as a software engineer at Bloomberg, where I work in asset investment management, helping them create interactive workflows. And during the nights, I maintain free and open source software, and one of them is Robyn. Now, speaking of Robyn, we come to the question of what is Robyn? Simply put, Robyn is a fast async Python web framework with a Rust runtime. But before we dive any further, I'd like to tell you a story, the Robyn story. So once upon a time, in the vibrant month of April 2021, there was a diligent university student named Sanskar. He was in the final year of his university and was supposed to submit a final year project. But like all the other diligent university students, he was spending all his time scrolling Reddit. And during that time, a major company decided to incorporate Rust into one of their projects, and Reddit was filled with the means of rewriting everything in Rust. And during that time, I was working on a project that involved a lot of Flask. And I had been using Flask for about 3 to 4 years during that time, but I couldn't help but be annoyed that Flask lacked async support. I was a JavaScript developer as well, and the lack of async support bothered me. So in a search for a solution, I asked myself, Sanskar, what would be cool if you could create an async Flask? You know what would be cooler? If it was written in Rust, by the way. And ladies and gentlemen, this is how Robyn was born. But we come to the most important question of the talk. Why the name Robyn? So I thought to myself that if I take care of an entity called Robyn, and if I nurture it and allow it to grow, then it would automatically make me Batman. So if for some reason I'm not responding to some queries or I'm a bit slow, have a bat signal beside you, and it's my moral obligation to come back to you. And since its inception, Robyn is hosted on GitHub, is licensed under BSD 2.0 Plus, it's currently under version 0.38.0, has more than 2,900 stars on GitHub. It's nearing 1 million installs on PyPI, but most importantly, it's under active development. So we have acquired certain sponsors over time, and I'm really thankful for them. But most importantly, a project that was started as a single-person project in my bedroom has more than 40 contributors now, and I believe that's incredible. But I am certain that at this point, someone in the audience must have had this question. Why do we need another framework? The ecosystem is flooded with so many frameworks. Why do we need another one? But before you ask, I'd like to explain the rationale myself. I'd like to tell you what's my metric of comparing the frameworks in the market and why I decided to create a new one. For me, performance is important. Then comes the ease of use. I believe that if a framework or a tool is not easy to use, or we shouldn't bother learning it. Then comes scalability. I like to think of it in two parts: the performance at scale and how the code is organized when the code base grows. Finally, the built-in features. Next, the built-in features. I believe that the built-in features are important. Otherwise, you can just write a framework yourself. Then comes extensibility. Then comes hacker or innovator friendliness, which I believe can be substantially improved. Then comes an end-to-end application timeline, and then finally the community. So if we have a look at any framework in the market right now, we somehow need to settle for something. If the performance is there, then it's not easy to use. But if the framework is made to be scalable, or then the built-in features do not exist. But if the built-in features are there, then it's not extensible enough. And I believe that hacker friendliness is something that we rarely talk about these days. We don't even give it enough respect. But community is pretty nice, thanks to you all. And I finally believe that end-to-end application timeline is decent, but can be improved. So with Robyn, we are trying to create a framework that excels at all the mentioned criteria. We're not there yet, but that's the eventual target. So calling Robyn a simple, fast async Python web framework with a Rust runtime doesn't do it enough justice. Robyn is based on three core principles. It's a high performance, community driven, and innovative friendly web framework. Now, speaking of performance, I will let the metrics do the talking. As you can see, according to Tech Empower, Robyn is one of the fastest Python web frameworks in the market right now. It can serve over 1 million requests per second, and we are only getting started. Now, let us have a look at the architecture to have a sense of why Robyn is way faster compared to all the other frameworks. So first of all, we have a Rust core. This is majority of what makes Robyn faster than all its competitors. We have a multi-threaded runtime, which is backed by Tokyo. This part allows us to use real Unix threads, allowing us to bypass the kill at various places. Then we have a worker event cycle, which basically does all the dirty work for us. This part manages the runtime. This passes all the instructions to the Rust code, initializes the thread pool, and all the incoming requests are routed to the thread safe router. And then when we start the app using the command python app.py, the Python code is converted to a Rust object. Then the multi-threaded router is populated. And finally, depending on the type of request that's coming and the type of function that's supposed to be executed, for example, a synchronous function or an asynchronous function, the functions are dispatched in the thread pool, executed, and finally the response is sent back. So this is the multi-threaded architecture of Robyn. Pretty cool, right? Now imagine it being way faster. In Robyn, not only you can have multiple workers, but also multiple processes. So you have a TCP socket, and what you imagine the multi-threaded runtime can scale across the cores of your machine. This allows for way better scalability. How you can use that? It's fairly simple. You do Python 3 app.py, specify the number of processes, specify the number of workers, and you're good to go. Now, let's talk about the ease of use. I believe that if a framework or a tool is not easy to use, most of us won't bother learning it. We already have so many hard problems to solve as engineers. And if a tool is adding to the complexity rather than subtracting from it, there's not a lot of point in learning it, or at least the experience is not that great. So let us talk about the Python app lifecycle. Initially, you'd have something like a reverse proxy, which is like Nginx, caddy. Then comes a web server, which is an ASGI, WSGI, Then you'd have a web framework, something like a Flask, Django, Fast API, and so on. Let us talk about the web framework side of things first. This is a Flask application, and you may know that I really liked Flask because I had been using it for a long time. And I believe that Flask is one of the most common frameworks that's used in the market right now. So how a Flask app works is that you import the Flask module, Flask class from the Flask module, you initialize it, add some routes. And Flask is one of the most popular frameworks in the market. And precisely for that reason, Robyn is based on the Flask API. You import the Robyn class from the Robyn module, you initialize it, and then you add some routes. I have changed certain APIs that I believe could improve the developer experience, but if you folks are aware on how to code a simple Flask app, the learning curves should not be very steep. It should be fairly simple for you to get started with Robyn. Now, speaking of the web server side of things, traditionally, you would either have a WSGI or an ASCII. So what a WSGI stands for is a web server gateway interface, and ASGI or ASCII is an asynchronous server gateway interface, which was the spiritual successor. So these were created to set a standard. These SGIs were created so that the framework developers could expose certain interfaces and the server developers could consume from those interfaces. The framework developers didn't have to worry about handling the HTTP requests, parsing, and the server developers didn't have to worry about basically routing, how the execution works. So on your screen, you see an example of a simple WSGI app. However, Robyn doesn't need any SGI. So whenever I tell this to anyone, someone is always like, what about TEP 333? What about ASGI? But my response is, if you read these PEPs or these documentations carefully, you will realize that this was made to make the collaboration between the framework developers and server developers easier. However, in Robyn, you get both of it packed in. We handle all the collaborations for you. So in Robyn, you do not have an external server component. Robyn ships with a coupled server. So you just need to set up a reverse proxy, and then the server can handle everything for you. So you just need to type the command python3 app.py, and you're good to go. And which is also one of the reasons why Robyn is much faster than all the other competitors in the market. So let's talk about scalability. First, we talk about performance at scale. And we have already talked about how Robyn is much faster compared to all the competitors. You can see the tech-empowered benchmarks. You can see the throughput. So what you need to do is set up a reverse proxy, then have a server, and you're good to go. Now, let us talk about the second factor when we talk about scalability. It's called the organization at scale. So Robyn, by default, supports views. So views is basically a way for you to set all the responsible HTTP methods inside a function. And this kind of views is very unique to Robyn. You must be familiar with class-based views, but Robyn also supports function-based views. So you can create your functions as closures, create a view decorator, have your get, post, all the HTTP methods inside this function, and you're good to go. Now, if views don't suffice, you have something called routers. Routers is basically like a Robyn app, but defined in a different folder. So it's a sub-Robyn app. So you'd initialize a router, you'd give your CORS request like you do in the main Robyn app, define the routes, and then define your routes accordingly. Basically, you have your get methods, your post methods, and segregate the application based on the responsibilities. Now let's come to the built-in features side of things. I believe that the framework should have sensible features that they ship by default because, in my opinion, having a solid foundation and doing the basic things correctly is the right way to go. Also, I wouldn't want to implement everything myself if I am learning an external framework. So Robyn by default supports synchronous functions, asynchronous functions, directory serving, static file serving, URL routing or path parameters, middlewares, and it supports application events. So you can have your startup handler, shutdown handler, and yes. So we believe in having sensible features by default so that the framework developers can extend upon them. Like if you want to create plugins, you can extend upon them. There are a lot of more features. You can have a look at the documentation. And now let's talk about extensibility. This topic is a close topic to my heart because I have been a person who has spent a lot of time extending his Linux PC to a custom config, spending hours to make my i3 config suit me. Extensibility is something that's very close to my heart. So Robyn, by default, provides you first-class extensions. So you can install a Robyn extension that we ship in, but if you don't agree with our implementation, you can just consume the interface and override it yourself. So as an example, you can see Robyn supports Jinja templates by default. What you need to do is to pip install Robyn templating. You can from Robyn templating, either you can import a Jinja template that the implementation we provide, or let's say for some reason you do not want to use a Jinja template, you want to use a template rendering engine of your choice, then you can just consume from the interface that we have a render template method, just define the response that you'd like, and you can use basically whatever rendering engine that you prefer. Similarly, we support GraphQL through Strawberry GraphQL. So you can just create your types, render Strawberry GraphQL, and you're basically good to go. Now comes the hacker friendliness. And this topic is where I support, and I'm a very strong proponent of making hacker friendly. The frameworks that we use hacker friendly. I believe that we focus on too many things like type safety, runtime validation, which are all good, but they are focused on a large team collaboration. We often forget the fact that all the large projects that we talk about were small projects at a certain point and were created when a person caffeinated themselves, maybe wrote it on a weekend sprint. Probably the code was terrible in retrospect, but it's also one of the reasons the project was scaffolded quickly. So in Robyn, you have features like const request. What const request is, basically some people would call it a cache, but I'd like to call it a const request. I'll explain you what const request is. So if you remember the architecture that we talked about, you see this part is very GIL dependent. This part requires you to acquire the global interpreter log, then release it when the execution of a function happens. I came to realize that this brings a lot of overhead. I asked myself, would it be possible if we could just store this function once when we are populating the router and then getting rid of the GIL completely? This would allow us to store certain static responses based in the router itself. So you'd have to compute the function only once, and that would then increase the throughput of your application substantially. So how you do that is you just need to specify a parameter const equals to true. And yeah, you would use it in features like JSON payloads, image serving, static file serving, basically or serving a simple string, basically where the output doesn't change a lot, but you do not want to waste your CPU cycles, and you can just store it in memory. Then comes WebSockets. WebSockets, in my opinion, are also hacker friendly because they serve the purpose of queues sometimes. It's also a core feature, but also a hacker friendly feature. So Robyn supports WebSockets by default. What you need to do is just create these routes, add certain decorators, and you'd have a first class WebSocket support. And most importantly, you do not need to choose a server. When you're working with the web framework, the paradox of this choosing a server is a lot in my opinion. You have something like Unicorn, Gunicorn, Uvicon, Starlet. So not needing to choose a server and having a couple server is, I believe, a very important factor in my opinion. However, if you want to, you can have a reverse proxy in front of the server to serve it accordingly. Now we come at the end-to-end app creation timeline. This is a term that I have sort of coined myself, but it's basically the time required for you to start an application from scratch and get it up and running in the cloud. So what the timeline for Robyn looks like is you do pip install Robyn, or you can either use Conda. Then what you have is Robyn CLI. And this is one of the features that I like a lot, is because you can just use the create command and we have certain templates. So current modern day backend engineering is not just setting up the backend server, it's setting up Docker, it's setting up the database. So we have certain templates that you can choose from. You just need to type the command Python and Robyn create, and we'll supply you with certain options that you can choose from. And you can have a project scaffolded in just 1 minute. Then Robyn's API design is a very simple API design. It's based after Flask, which was also sort of a micro framework when it came, and was, I believe, follows a lot of hacker friendliness approaches. And finally, if you're in the zone, you do not want to go and have a dig deep in the docs, you can start the docs from the CLI itself. You just need to specify the docs flag, and you will have the docs with you. And finally, once you have gotten your app, you have created your API, you have read the docs, you just need to specify the workers and the processes, and you have it up and running. Because if you remember correctly, the Docker file was supplied through the scaffolding. All you need to do is configure the workers and the processes. Now, let us talk about the community. We can loosen our belts a bit because the technical part of the presentation is over. Before we end this presentation, I'd like to tell you one final story, the community story. The community started like all the other great things start with the post on Reddit. I had created a chat channel on Jitter because I enjoyed talking with people who may be interested in Robyn and people who used Robyn. But during the final part of 2022, I got a bit overwhelmed due to certain events in my personal life. And then during that time, we also migrated to Discord. But come November 2022, certain events left me very overwhelmed. But I was still putting in the effort, doing some PR reviews, but I couldn't contribute as much. But when I had a look at my community stats and at the project, when the personal overwhelming went away, to my surprise, we still made progress. The community just stepped in. They allowed me to take my time. They volunteered. For that reason, I came to this conclusion that the community was growing at a steady state. Many features that were being included in the past 2 months during that time were recommended by the community. 60% of the releases had some sort of community involvement, and 4 out of the past 10 releases required the minimal involvement from my end. And for that reason, Robyn was converted from a single person project to a community project. And it's hosted under Sparkles. Sparkles is an organization that aims to create Python web frameworks and aims to elevate the Python web tooling. So you can check it out. It's hosted at github.com/sparkles. And for the future, what lies in future for Robyn? We want to always keep adding performance optimizations. Robyn is one of the fastest frameworks, and we'd like to keep it that way. Then we'd like to add certain open API documentation generation. This is work in progress, should be merged hopefully soon. Then have certain runtime data validation as a first class extension. Then it's a feature that I've been experimenting around, that if we can somehow tell the compiler to implement automatic const requests, the developers won't have to do it themselves. So it's a feature that's still in very early stage, but we want to experiment with that in the coming months, add certain first-class ORM support. We have the templates that do the scaffolding for you. So now we have Prisma integration, SQL Alchemy integration. And yes, so you have certain first-class support, but if we would like to have an ORM for the people who prefer that, we'd like to add something ourselves, then add certain authentication and authorization defaults, improve WebSockets, improve the documentation, create certain video-based tutorials, more text-based examples, and finally add certain support. So add an AI-based support to the website that would allow the community to focus on shipping features. However, still increase the human-based support around the application. So I have been dedicating a large chunk of my time providing certain support on GitHub or on Discord. So if you'd like to help us out with that, we are with PRs, reviews, just helping with triage, or would like to just talk to me or talk to the community. We have the community on Discord. We host monthly community calls, and we might have the next one in the next week, probably. So here are some of the important links. We are hosted on GitHub, PyPI. The website is Robyn.tech. Docs are present here, and this is the Discord link. So star Robyn on GitHub, and you can ask me any questions that you may have. Thank you.
Thank you so much, Sanskar. That was amazing. I'm really looking forward to giving it a try myself, especially as I've mostly used Flask myself for my toy projects, and I'm really getting into Rust recently. Okay, we have time for a couple of questions if people want to ask any in the room. Okay. Well, I have a couple of questions. So what's your what's your one killer feature that you really want to get in the next couple of months? And my other question is, what do you think has driven so many people to join the community recently? Take your choice.
Take a choice of one of those two questions?
Choose one.
I think I can answer the community question first.
Okay.
I believe the community is because, for one, I emphasize on shared ownership of commits. For example, there are many commits that may be not very polished by the contributors, and we may have to rebase it. But I created a tool that's called Add Co-authors. So in Robyn, if you go through the commit history, you'll have multiple co-authors to give the attribution where it's due. And I also think the popularity of Rust is driving certain traffic towards Robyn. And Robyn is much faster compared to all the other frameworks. So all of this combined together is, I believe, what's driving support.
Yeah, amazing. Okay, we have a question in the room as well.
If we have an API that uses quite a bit of Python logic when delivering requests, what kind of performance increases can we expect? Because I'm guessing that the Robyn, the wrapper does the performance with Rust, but if you're having logic in Python, it would still probably be slow.
I compared to, let's say, if you're comparing it directly with the Rust implementation, it will be slower. However, if your logic is in something like Fast API, Flask, Django, then it will be way faster. So I just showed the tech-empowered comparison. So Robyn can serve over 1 million requests on the same logic, and whereas Flask or Fast API would serve like 200 or 400,000 requests. So you can expect like 2x or 2.5x the performance.
Is that for...
However, comparing it to native code directly would be a bit slow, but also a bit unfair.
Is that benchmark based on like I guess a simpler request like returning hello world?
So Tech Empower has like various kinds of benchmarking suite. So they have like JSON serving, static like simple hello world serving. So you can have a look on how the benchmark works, but it's on a variety of things.
Okay, thank you.
Thank you. Do we have any other questions in the room? I'm fine. All right. If no other questions from anyone in the room, I think we'll wrap it up there. Unfortunately, we had to move this to remote at the last minute, so I've got your gifts here. Unfortunately, I can't send them to you, so we'll have to ship them later. But thank you so much.
Thank you so much.
And yeah, so that's that. And we've got our afternoon tea break right now. And we've got lightning talks later in the afternoon. And don't forget to pick up your t-shirts if you've got one. Right. Round of applause for Sanskar.
Thank you so much. Thank you, everyone.